little introduction on what will be discussed today. We will talk a little bit about Tetris, the main things about it. Then we will switch to how to recreate the game in 6 steps. Then we will talk about how to create your own music in Hypehype. Also, I will talk a little bit how to try, try and record this music right in the editor and publish it. And I will publish this level so you can try to do this yourself. I will do this in this live session. So, okay, about the Tetris. Yeah, this is an awesome game that, as for me, started the whole game development industry. This game is a pure legend. You can talk about it for ages. There are few devices that actually don't have Tetris installed, or at least a possibility to install it. If you have never played this game before, well, you definitely have to. Uh, Also, I've created one here in Hypehype, so you can check it on my profile. And today I will talk about how it was created. So let's move on. Um, what is Tetris? Tetris is a classic arcade game created in 1984 by Alexei Pajitnov. His idea was to program classic pentamina game with falling 5-block pieces. Unfortunately, performance of the electronics that time was not enough for that, so it was considered to simplify the task. Use only 4 blocks out of 5. The game requires players to rotate and move falling Tetris pieces. Player clear lines by completing horizontal rows of blocks without empty cells. If the pieces reach the top, the game considered to be over. Okay, let's talk a bit about pixel animations. Pixel movement illusion is created by turning on the new pixel on the grid and turning off the previous one. Instead of moving those pixels, we just switch them to trick the brain. Okay, let's move on to recreating Tetris. First of all, the first step is the grid. Here only the fallen pieces are displayed, as you can see on the screen. What about the active pieces? We will talk about it later on. The grid is just a two-dimensional list of numbers with indexing starting from the top left corner. So I hope you can see this my cursor. Here it is on the screen. This is top left corner, and there we go the x-axis. So this is 0, 1, 2, 3, 4, 5 to 9. And here 0, 1, 2, 3, 4, 5 to 20 or 16. It depends on different types of the game design. Okay, each color can have its own value. So as you can see on the screen, for example, first value 1 is considered to be red, 3 is blue, 2 is violet, and so on. Or you can just store here zeros and ones. 0 is no block here, 1 is a block exist here. To make this list one-dimensional, each next row from the top, you can add 10 to the index. So here you start with 0, 1, 2, 3, 4, 5 to 9, then you go 10. 0, there's 10, 11, 12, 19, 20, and so on. So it goes like this, starting from here and going there. Okay. Step 2, the pieces. As tetra means 4, each pieces have 4 blocks that can be only connected by their edges. Also, the pieces that can be made with 90 degrees rotation considered to be the same one piece. So, for example, if this piece lays horizontally, it's the same I piece. Okay, if we will try to make all possible arrangements using those rules, we will come up with all those 7 pieces. You can try that yourself. So all those pieces have their own letter, inspired by the unique shape. So you can see here I piece, J piece, L piece, O piece, S piece, T piece, and Z piece. That's it. Let's move on. But how can we store information about the active piece? As we always have only 4 blocks, the best we can do is to make one center block and 3 connected to it. This is actually my own idea. I didn't see any tutorial that makes it like this. Most of the people just make another grid with the piece itself. But they do actually separate those 2 grids too, as me. Okay. It's the center block will store the absolute coordinates that gives the position relative to the start of the grid. This center block will help us with rotation in the future. So here on the grid, for example, if the block is placed on the coordinate like this, I hope you can see my cursor lighting up the place. So it will be on the grid on the place 0, 1, 2, 3, 4 and 0, 1, 2, 3. So its coordinate will be 4, 3. This piece will be centered here. Okay. Connected blocks will have their local coordinates relative to the center block. This way you don't need to change those values when the block moves, but actually not when it rotates. So here's the value, for example, for L piece. This block is, for example, this block one is located above the center block. Its position is considered to be 0 or -1. Why -1 if we are above this center block? It's because we consider the y-axis to move from here, from the top left corner, to downwards. So it will increase in this direction. So you can see it do the same thing here. -1, this will be 0, and this will be 1. And moving on axis will increase its value here, the first value. So this is 0, this is 1, and there can be 2, for example. Okay. Step 3, polling. Now we need some action. Each move downwards happens automatically. The delay can be decreased slightly over time to make the game more challenging. This move changes the y coordinate of the center block on -1. On +1, sorry. Because it moves downwards, and as we discussed, the direction is from the top left corner to bottom right corner. Connected blocks don't change any coordinate as they relate to the center block that moves same as they are. We start moving down until we suddenly reach the bottom of the pit or a pixel on a grid. What should we do then? That's easy. Before moving, we need to check each block of an active piece on collision with the grid. So the block's coordinate must not be bigger than the last row. It can be 20 or 16. It depends on the grid you have chosen. And then we check the pixel on the grid with the same coordinates. So let's how that happens. For example, you have this I piece that goes down and reaches the end. We check the next movement and check each block of the of this eyepiece on collision with the screen. So we see the center block, and 3 connected ones to it on if it was collision in here. How do we do this? Again, we have the absolute coordinate for the center block, and we can just add to those coordinates the offset of the connected blocks. And try to see if there are some block or the pixel on the grid or block have reached the end. Okay. Now, step 4, update. If at least one of the previous rows was broken, so we reach the end or we have reached the pixel on the grid, we need to draw the block on the grid. Just change the value on the grid on the block's coordinates to the color or the block, or just to 1. As shown on the picture, there's only zeros and ones. Okay. So lastly, you need to check each row from the top to the bottom if the row is full. So we check from here, then there. We check if there's at least 1 0. If it is, we go to the next one. If it's not, for example, for this, we go here. This is not 0. Here, go over to here and go and stop. If this row, for example, was full of ones, then we set the whole row to 0 and move all the rows above on the one block below and continue, of course. So step 5, moving sideways. After the step 3, this one will be pretty straightforward. Again, this is the step 3, the falling. This is the sideward movement. Firstly, we need to create buttons, of course, for inputs for the movement. On each click, we now change the x coordinate of the central block on +1 or -1, right or left accordingly. So if we go right, we will give +1. If left, -1. Okay, the same as with falling. We need to check if any block reaches the border or a pixel on a grid. But here, instead of placing the block, we just won't move at all. That's it. Okay, step 6, rotation. Yeah, this is where the geometry kicks in. When describing the pieces, we have made the center block and 3 connected to it that have coordinates relative to the center block. Now let's look on the picture. I hope you can see it. And see what's happening with the coordinates on clockwise rotation around center. So you can see here 2 dots, m -2, 3, and m with a quote mark or inverted comma with coordinates 3, 2. Okay. This is the rotation clockwise from m to m with inverted comma. What you can see here, if you look closely, you can see that the values 2 and 3 are suspiciously still in here after rotation, but swapped and not negative anymore. If you repeat rotation and try to connect all the points, you can came up with a single formula. So here you can see that -2, 3 becomes 3, 2, becomes 2, -3, -3, -2, and again -2, 3. So it goes through the full rotation. You can came up with a simple formula. So xy coordinates of the offsetted blocks connected to the center block. It will become y minus x. That's it. It will work for any of the block. So, of course, we need to acknowledge the elephant in the room. There's no need to rotate all block, as we will only create confusion. As you can notice, the O block still have its center block, and it's not quite in the center of the O block. Center of the O block is in the middle of it. So yeah, we just need to code that this block won't rotate at all, just like that. Also, you can notice that the I, S, and Z blocks also have some kind of rotation symmetry. So it will be much better to have only 2 rotation for them. Like on the picture, you can see that S and Z blocks and I block have only two rotational points. Then they go backward. So after the first rotation for them, you can just reset the connected block positions or just use a mirror formula for that. So here it is, xy becomes minus yx. How is it mirror formula? I can show that. So xy becomes y minus x in this formula, first one. And in that one, it becomes a mirror formula just which swaps the minus. Now it's minus yx, y minus x minus yx. Okay. That's actually it for the Tetris creation. Now we can proceed to the music creation in Hypehype, or I can hear any question on the topic of creation the Tetris itself. So, yeah. Um, GOP, can you hear me?
Yes, so next about music creation. So you want to show your screen? Or about the
For now, yeah, I will. No, I will continue with presentation. Is there any question in the chat, or is this topic is too hard for that?
Well, that was definitely way too much information for me in such a short time. But people in the chat, do you have any questions about this? I can see that Salzburg is currently studying this kind of math that you showed. But do you have any questions about this part?
I can go back. Okay, I can go back and show any slide you have seen again, so you can like ask question about this slide.
Yeah, if you have any questions about any of this, the way Tetris was made, ask them in the chat.
Okay.
So someone can answer
okay,
you.
I understand. So,
well,
I think
it
we
seems
can
that there are no questions
go...
right now, but we can ask if there comes up any questions later on. We can answer them 10, or you can answer those 10.
Okay.
And Gaming with Soul says that good explanation. I like it, so that's nice.
Thanks a lot. Okay. Yeah. Okay. Let's proceed to how to make the music in Hypehype. Firstly, we need to know how to display the music. I actually don't really like the method currently the music is displayed via notes and so on. It's not really, it's actually pretty hard to get used to this system and to play the music. Just you can see the notes and you play this music on some instrument. I don't like actually this method with visual notes. So I actually like this method I will show here. So it consists of blocks that have some duration. Here they have only 1 bit duration, but sometimes it have different duration. Okay, so music can be displayed as a sequential performance of individual sounds or notes. This way you can only have one sound that can be activated many times with different pitch. So you can test music like this. For example, on this site, I will post the link in Discord after the presentation. So here it is. You can just tap on different places, create this music what you want, and play it right in the editor. Okay, let's talk about the JSFXer. Don't know what J means, but it's like a sound effector, something that helps you to pick the right sound effect. For Tetris music, I have used the sound generator that is available in Hypehype for now. This logic component is very powerful as for me, as you can create really many sound effects for your game. To make a sound, you can try a sound on the official JS FXer site. There are 11 different premates already shown. So from the pickup coin to tone, or you can, for example, play around with the sliders on the top, on the right side, to make different sound effects you want to add to your game. Okay. For more information, you can just go to Hypehype, to sound generator, and to Hypehype wiki related to this component. Yeah. To make Tetris music, I have used the simple tone premade with starting frequency 4040 Hz mostly. The note is La or A4, if someone knows what this means. This is pretty common first note. It used pretty much everywhere. Changing only the pitch parameter for the okay, I'm changing the pitch parameter of the sound generator in my Hype, so that it makes different sounds or notes. Okay. You would ask where to find notes for the music in this style. Not in notes that are very common, but in the style I am presenting you. I personally search for music in YouTube like this. I am searching for the music name. You put the music name here and add piano. So it's written like, for example, Tetris piano or Rick Astley piano. Okay. Also, in particular for the Tetris music, I was lucky to find the original Karabeniki 8-bit music being deconstructed in the oscilloscope. You can check this video too, Tetris oscilloscope, and yeah, it's pretty interesting to look how the different sounds, how the different melodies for this whole song sound like. Okay. Now I want to show a bit about the two melodies actually in Hypehype. Hope the time will be on my side. Yeah. This is two meme melodies in Hypehype. First one is from the song Astronomia, better known as hashtag Coffin Dance. Yeah. Here's the melody itself on the screen. I have made in the site I was talking about previously, musicboxmaniacs.com. But yeah, you can actually find many different editors that have this feature with notes like this. Yeah. Okay. Now I will show you this same melody, but now all the notes pitches are represented in values for easier coding. So here it is. Yeah. It's firstly very confusing because there are only values and not more like that. It's not visual and so on. But it's much easier to code all this stuff in Hypehype and anywhere else. Okay, what are these values on the top? These are the beat. So it's the first beat in here, second one, third one, fourth, fifth, and so on to 16. And I have divided this part of the song into two pieces so that it's not like a single really long line on the screen, and you can see it all. The whole melody is 16 times 2 is 32 beats long. So yeah, it's the same song relative to the note do. So it's the first like note or a note C5. You can see it on this like picture. So yeah, this is -6. This is 0, -1, -2, -3, -4, -5, and this is -6. And again, -6. This is 0, 1, 0, -1, and so on. So you can hear all, you can see it all here. -6, -6, 1, -1, and so on. Okay. Now, if GOP can you please now go to the editor, and I will show this same melody coded in here. GOP,
Alright, now we are
can you
in
hear
the
me?
editor view.
Okay, that's great. So, as you can see, yeah, it's pretty cluttered on the first view, but actually, it's not that hard. Actually, there are only 1, 2, 3, 4, 5, 6 different components that you actually need. Okay. Uh, Else here is just the repeated thing for the notes. So yeah, it kind of looks scary, but if you will try it yourself, it won't be like this. So yeah, let's hear the first melody. Yeah. And this melody will repeat after it will finish. You can code it anything else, so it can like stop, or you can go to another piece, or you can, for example, create many different voices for your song, so it will be more like deep and so on. Yeah, pretty interesting stuff. Yeah, like that. Um, and now, GOP, if you can, please turn back to the presentation. Um, I want to share a bit about the second melody.
Alright, we're back in the presentation.
Okay, hope you guys can see it. Oh, sorry, I have. Oh no, I didn't. I didn't reconnect. Okay. So melody 2, yeah, I have made 2 melodies, so it's an easy one here. We started with it, and this is one is a bit more complicated because it have repeated pattern that will be just you won't need to code it. You just can make one single part, and the editor will repeat it for itself. How we will think about it a bit later. So, okay, uh, this melody is, yeah, it's Bad Guy. I think you guys know this song. It's pretty common, pretty like everyone you knew this song. It's meme and so on. Okay, so what it consists of? It consists of 4 parts. Some of them are repeated many times. So the first one here is yeah, I'm bad at singing, sorry. This part will be repeated 4 times actually. Then we will be so it will be repeated twice, and then the last part here. So it will be the last here. Um, and here you can see all the notes that are needed for this song. So we have 8 beats here, and we like start from the first one here like -5, it's in here C -5. Yeah, as we have talked in the previous um, about the previous song. Okay. Now, can you please again go back to the editor GOP?
Yep. Editor is now
Okay.
visible.
Yeah, and now I actually want to recreate it in online. I hope, yes, I have 30 minutes. It's great. I hope it will be good for me. So we start with adding the simple interval to our hype, um, something like that. Uh, So what we will do here, we need to change the duration. The best duration is for me is 0.2. So it's 5 beats per second. Yeah, we should make the looping on, so it will be it will loop. Yeah. Um, uh, then we need the actual value of the bit. Here, just add variable. Um, yeah, it starts from 1 and will continue on. In different zones, it will go to like 16, 8, 32, or something like that. It's these all values are the power of 2. So it's 2, 4, 8, 16, 32, 64, and so on. Yeah. Um, then we need to add the compare block. Here we will add the compare block, and it will if the bit will be bigger than what we need it to be, we will just or we will cut this on, or we will repeat it again. To cut it, you just on true. If the output is true, we will set the interval, activation, enable, off, like that. So here it is. If we want to reset again the music, we can do this. We move here, output value, and will set the value to 1. Okay, like that. If false, if we are not greater or equal than the bit for our song will be the maximum one is 32, if I remember it correctly. Yeah, it's 32. Yeah. So if we are greater or equal than this value, then we will we are if we are not greater or equal, if we are still playing the music, then we will output value add value 1. So we will each time increase the value of the bit on 1. Okay, something like that. Uh, so one moment, I will uh, see how it's okay. What should we do now? Next is we set this interval to firstly execute the our bit number, and then to execute the compare block. So it will play the note and then it will go to the next bit, like that. Then we will need to add the sound itself. There I have make the sound, electric piano. Yeah, it's it. You can hear a preview. Sorry for that. You will only hear it in the play mode. Okay, and now all we need to do is to make the note itself. For the note, for each note, we need a compare block equal, starting with 1, yeah, and uh, variable. So two things, pretty straightforward, I think, I hope. And if true, if this bit equals 1, we will execute this variable. What this variable will do? It will store the information about the pitch of the note. So my melody starts with pitch -5. here it is. Output to sound, tune, its pitch, but with other, it's another word for this same thing. Yeah. What we should do is just connect it here, and it will change the tune of the sound. Yeah. Uh, Now we need all we remain to do is to connect the variable to the compare block. So value A here, here, and that's it. I hope. Yeah. One moment. One moment. First of all, or that's it. Okay, that's it. Yeah. So this way you have created yourself a music player. I hope it works. I will try that now. Yeah, it works. Now what we have remained to do is just copy this thing and set the values we have talked about before. Notes. So, oh no, we don't start with -5. We start with -6. 6 here. Then just repeat. Repeat again. Again -6, but the beat will be 3 because there's a pause. This is 1, 2, 3. Okay. Now we will repeat again. This is will be 4. This is will be 5. Yeah. This is 1. The sound 1. This is -1. And so on. Yeah, I will just repeat the same thing again and again in hope of something different. Isn't it a sign of madness? Yeah. -3. No, it's not a sign of madness. It's actually programming. 7, 9. Okay, on the bit 9. And we can just have this again here. -4, -4, and -1. Yeah, like that. I hope we have enough space in here. I will move it a bit here. Так, the last 2 bits here. And the bit itself,
Oh,
9, 10,
currently,
11. Yeah.
my app crashed, so I need to start spectating again. So I'll, for now, switch back to the presentation view.
Okay, okay. I hope
For
you
just a
can at least
moment.
hear me. Okay, okay.
Yeah, I can
I'm
hear
still
you good.
creating.
That's just this video.
Okay, okay.
All right.
We are back, I hope. Yeah.
So now we are
Yeah.
back in the editor.
15. For example, 5. No. Okay. It doesn't work like that. 5. Here it is. And 15 and 16. 1, 10, 16. Okay. Now we need to check if it's all working. Again, we will repeat the same process of giving the information what bit it is. Bit is stored in here. I will call it bit in here. Yeah, you can see the what was written here. Anyway, okay, and we repeat again. Sorry, one moment. And also the variable need to be connected to the compare block. So the compare block will compare it to value 32. Yeah, like that. And let's go on, repeating the same process, expecting different results. Let's go. Like here. I hope you can see the process. Again, repeating the same thing. Yeah. And I hope it will work in the play mode.
I think it's playing.
Something is not.
Yeah.
It's playing?
Yeah.
Or it's not playing?
I think it's playing.
Okay. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, something is wrong here for some reason. Maybe I didn't make the different values here. -4, -1, -3. Yeah, I forgot. And -4. Yeah, this is the first part, and yeah, we have the second part of this song. Dun, 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 dun. Yeah. So here's the value 17, if I remember it correctly. 17, 18, 90, 90. Copy that. So it's -6, and now we go for the 9. 9 here. This is 19, this is 20. And go on like that. 21, 8. Then we can repeat this 2 times. So 21, 22. For the beat 23, 24, 25. And here's the same values except for this note. It will be -6. Clear, 6, -6. Yeah, like that. 8, 9. Hope I didn't make a mistake somewhere in here. And again, this part repeats twice. 25, 26, 27. 27. How much block is it? The 7, 28 block wide. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. And like that, we have created already created our first zone. Okay. And then we need to output the bit on which it will be represented. So here it is 1, 2, and so on. And we don't just execute. We need to transport the value A, value to value A, so that compare block will compare this value of the bit to the actual node. Will this node be executed here or it will not? Again, repeating the same process. Yeah. And the last one here. Yeah. So it, in theory, it must work on the first try. Yeah, it works, and as we have created it like so that it loops, so it ends and it goes backwards. In here, again, we have made if the value of the bit is greater or equal to 32, we just reset this value. So set to 1. Else, we will just add 1 to the value. So it was 1, it will become 2, it was 2, it will become 3, and so on to 32. Yeah, okay. We have created the first one, but what about the second one? I hope we will have enough time for that. I'm not sure actually, but we will try. You can try to make something like this yourself. Again, what we will do, we will need an interval, we will need the variable for the bit, um, and we will need the compare block. So we start with executing, as I remember it correctly, start with executing the variable. Okay, I need to finish this thing firstly. So what is added here is the switch block. This is actually pretty powerful block. Can be used in many different ways, and we will use it here for the repeated parts of the song. Um, so we have this switch block, and we have uh, the box that will show us the part of the song we are on to. So we will have the 8 parts of the song for the bad guy. Yeah, and let's try to do this. So what we will do? We will we will repeat the 4 times the one piece, 2 times the second piece, and 1 time uh, the third and the fourth one, and then we will go back. So what we will do here is we just switch integer decimal range switch. Here what we will do, we will start with 1, uh, proceed to 5 as 1 plus 5, 1 plus 4 for different parts that have the repetitive um, part in it, melody in it. So we just 1 plus 4 is 5, and then this will go for 2 parts. 5 plus 2 is 7. Then we will go 8 and 9, if I remember it correctly. So like that, we have created the switch here: 1 to 5, 5 to 7, 7 to 8, 8 to 9. Can you play? Play the first this first song. I can play it. Can you hear it? I hope you are.
Yeah, that's me heard.
No, it's just okay. Yeah. Okay. Um, So, about the bad guy, the second song. How many time? How much time? 10 minutes. Okay, I will speed up here. So. Okay, while you, let's connect all those pieces. Let's add firstly the note itself, the sound block. So it's here. Think electric piano. Okay, I will try to fit in my time. So what I am doing, I am firstly executing the variables, then the switch, and then the compare. So what we do, firstly variable, then the switch, and lastly the compare block. Okay, 1, 2, 3. Now for the uh, bit, bit will be to compare block, so it will go right here. Again, like in the previous, in this one, um, to compare, and there we will have only 8 notes. Even though it's only 8 notes, we will have also 8 parts. So 8 parts by 8 notes, we will have the song that will last for 86 bits. But we will only code 4 parts of this song. 1 minute. Okay. So the compare block will add 1 here, will set 1 here. Yeah, so the compare block. Compare block, when we will reach the end of the part of one of the parts of the song, greater or equal on true, it will what we will do, it will just output value, if I know it correctly, output value here, it will set the 1 here without executing, and here it will give us the parts will be increased by 1. So without execute, if I know it correctly. No, it's with execute. We will execute also this thing. So I'm not set add. We will each time add 1 to this part as we reach the end of the part. Yeah. Yeah. Then we output this value to the switch. Switch value. Here it goes in the switch, and switch on the end on the default value. So if it will be bigger, the value will be bigger than 9. It will be 10. Then we go to default. Default, and default will what will be executed? What will be executed? No, it won't be executed. We will set the value to 1. So what we will do on default, set value to 1. So we will go back to part 1 on the last after the last part. So. Okay. Have I done it all correctly? I hope so. Here. Did I do this? All this? Oh no. So if false, if we didn't reach the end of the part, we will just set not set add 1 to our bit. This is the bit tact. If you know this on Russian, it we actually pronounce this as tact in Russian. Like this. So. And now what we need to do is again to make all the nodes. To make the nodes, again, we need a compare block where it's on -1 on Z, it must be on 0. Compare and variable. So this is a node. Compare will will be executed on the right bit, and this will give us the right node. We start with -5. I can make it like this. If true, execute, like here. So now, yeah, on case 1, we need to play this sound. This sound, output, tune, yeah, and like this, we have created our first sound in this song. So let's test this out firstly. And yeah. Don't forget to set the interval to duration 0.2 and to loop this thing. Okay. Hope it works. It's the last song. I forgot to turn it off. It doesn't work for some reason. Why it doesn't work? Switch variable compare. Yeah, it's a bit pity. Compare A. This. Yeah. Compare, execute. Wait, yeah, and you need to output the value of the bit without executing. You need to share the value here, and it will be executed by switch, but it will give the value of the bit from this variable. Yeah, it works. Now it works. Let's move this a bit up. Now let's create the bad guy song. 1, 2. This is sound 2. Again, right here. 1, 2, 3, 4, and 5.
Well, since we
Max
have
5,
just a
2.
few minutes left, I think you can continue
Yeah.
and make this in the stream.
Without the live session.
It doesn't really matter in this case if it goes a
Okay.
bit over time. We can just
Yeah. We now
from the next
have
session.
the repetitive part. Yeah, we just set the node, set executed. Yeah. Let's for now move on to the South Park. I hope he have some good things to show you guys. So let's move on to him, and I will stop the presentation.
But yeah,
Okay.
thank you, Zemander.